Trigonometry, Chapter 4, Graphs of the Circular Function, Section 3, Graphs of the Tangent and Cotangent Functions, Video 3, Changing the Period and Amplitude of Tangent and Cotangent. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we constructed the graphs of tangent and cotangent. For example, here's the graph of tangent. Period is pi, distance between pairs of consecutive asymptotes. Asymptotes at odd multiples of pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, etc. X-intercepts at multiples of pi, 0 pi, 1 pi, 2 pi, etc. Branches are increasing between pairs of consecutive asymptotes. And the quarter period behavior is vertical asymptote, -1, 0, 1, vertical asymptote. This particular cycle begins at x equals negative pi over 2. Now, as we proceed, we will focus on the interval negative pi over 2 to pi over 2, which captures one cycle between asymptotes and includes x equals 0. In this video, we discuss changing the period and amplitude of the graphs of f of x equals tangent of x and f of x equals cotangent of x. But first, why do I use quotation marks when I say amplitude? Think about it. That's because tangent and cotangent do not technically have an amplitude, but if it did, it would be infinity. Recall from the graph of sine or cosine, amplitude was the distance from the midline to the highest or lowest y-coordinates. Here you see the graph of f of x equals sine of x, illustrating its amplitude of 1. Alternatively, it was half the distance between the lowest and the highest y-coordinates. In this case, the distance between 1 and -1 is 2. Half of that is 1. However, the branches of the graph of tangent are unbounded. As the branch approaches an asymptote from its left side, so coming in from the left side of the asymptotes, the y-coordinates approach infinity. But as branches approach an asymptote from its right side, so think about the asymptote and coming in from its right side, the y-coordinates approach negative infinity. As such, there is no amplitude. However, changing the amplitude for sine and cosine was really just an example of a vertical stretch illustrated by the amplitude. When we stretch the graph, whenever we stretch the graph vertically of tangent, we can keep track of the quarter period points whose y-coordinates are plus or minus 1 at the odd multiples of pi over 4. So it's these points that will help us reflect the quote-unquote amplitude, the vertical stretch. For example, let's sketch the graph of f of x equals 3 tangent of pi over 2x. Like f of x equals a sine of bx, numbers multiplied in the tangent function change the period and the amplitude. They invoke stretches. For sine and cosine, the new period was 2 pi over b. That's because the original period of both was 2 pi, sine and cosine. But the period of tangent is just pi. So what do you think the new period would be generically? The period of f of x equals tangent of bx is pi over b. It divides the original period by b. In this example, the new period would be pi over 2, the pi on top being the period of tangent, the pi over 2 being the coefficient of the x, and that simplifies to just 2. Now, what interval will we sketch? With sine and cosine, we always started at 0 and just kept going until the end. But for tangent, we don't start at 0. Remember, we're focusing on this, where is it? On this interval from negative pi over 2 to pi over 2. So how do we adjust that interval to reflect the new period? As mentioned earlier, we'll focus on this interval, negative pi over 2 over pi over 2. By the way, parentheses, because those values are undefined in tangent, locations of vertical asymptotes. This interval does capture one cycle between asymptotes and includes x equals 0. However, the period for the interval, negative pi over 2 to pi over 2, is pi. We need an interval whose period is 2. We adjust this interval the same way we adjust the period. by dividing the endpoints of the interval by b, which in this case is pi over 2. So just as we adjust the period, we similarly adjust the original interval negative pi over 2 comma pi over 2 by dividing both of its endpoints by pi over 2, or whatever b is. In this case, it changes the interval to negative 1 comma 1, which has a length of 2. Good. So the new interval will be negative 1 to 1, and since the period is 2, the quarter period is 2 over 4, which is 1/2. So starting at negative 1, our quarter period behaviors will occur at negative 1, negative 1/2, 0, 1/2, and 1. But the quarter period behavior for tangent is vertical asymptote, negative 1, 0, 1, vertical asymptote. As such, the graph of f of x equals tangent of pi over 2x, notice I lost the 3, will have the following. At negative 1, vertical asymptote. At negative 1/2, y is equal to negative 1. At x equals 0, y is equal to 0 because it's an x-intercept. At x equals 1/2, y is equal to 1. And at x equals 1, we have a vertical asymptote. What about the 3? Well, the 3 invoke the vertical stretch. So how do we reflect that? We reflect that here as the quote-unquote amplitude. This will multiply each y value by 3. So the highlighted y values all get multiplied by a and become negative 3, 0, and 3. Of course, the 0 stays the same. Now we can draw one cycle of the graph. Draw the asymptotes, the points in between, and connect them, and it would look like this. Now we can replicate branches and asymptotes as desired by simply copying and pasting on both sides. Ad infinitum. As before, if a is less than 0, the graph is reflected across the x-axis. This happens automatically when multiplying by quarter period values. Just to show you what I mean, if the 3 were negative 3, then these 3 numbers would be 3, 0, negative 3, and then hence display a decreasing behavior between asymptotes because it would have gotten reflected across the x-axis. So to summarize for f of x equals a tangent of bx, and I will admit that this is a big theoretical summarization from that one example. The period is pi over b, and the quarter period is pi over 4b, 1/4 of pi over b. The interval of interest, we take the original interval negative pi over 2 to pi over 2 and divide it by b, or equivalently negative pi over 2b comma pi over 2b. There are vertical asymptotes at x equals the endpoints of this interval, plus or minus pi over 2b. There's an x-intercept at 0, and the quarter period points y coordinates are multiplied by a. Specifically, the graph contains the points negative pi over 4b comma negative a and pi over 4b comma a. Now, if all the summary here, the theoretical, is throwing you for a loop, as long as you understand the process of adjusting, finding the new period, adjusting this interval to reflect the new period, finding the quarter period, which should be straightforward, locating the quarter period x's and identifying their behaviors, then you can just sketch the graph. Oh, and changing the quote-unquote amplitude is necessary. Then sketching this graph is fairly straightforward. This is for the people that like everything summarized. And by the way, we can do it for cotangent as well. Main difference on cotangent is the quarter period behavior is decreasing. So 1, 0, negative 1 in the middle. And the interval of interest is at 0 comma pi. Because remember, when you go from tangent to cotangent, the asymptotes and x-intercepts trade places. So I invite you to pause and read this if you would like. But I'd like you to pause and try the following. Give you a function, ask you some questions. Give it a try. This video is kind of going on long, so be it. All right, if you haven't paused the video yet and tried, here are the solutions. Period is pi over 4, and 1/4 of that is pi over 16. If you take the interval negative pi over 2 to pi over 2 and divide it by 4, you get plus or minus pi over 8 for the endpoints, and so those are the vertical asymptotes. X-intercepts at 0, and the quarter period points are as listed.